Today we will study a relative motion, and in this we will try to learn the concept of least distance of approach. This is a sample question. We have two cars, A which is moving due north with 10 meters per second and B moving due west with 20 meters per second at a distance of 10 kilometers from each other. They are at a distance of 10 kilometers from each other, and car B is in northeast of car A at the same time. So find the least distance of approach between them. This is what we intend to find. So let's draw the two cars first. This is car B and this is car A. It says at some instant car B is in northeast of car A. So this is the angle 45 degree because car B is northeast of car A, and this distance is 10 kilometers. So this is the question. We want to find the least distance of approach between them. Now how to move ahead? Let's try to understand a very basic concept in it. Suppose this is a tree and this tree is lying on the side of a track. A boy is moving on his roller skates along this line, along this road. The perpendicular distance of the line of motion of the boy from the tree is, say, D. So what can you say about the least distance of approach between these two objects, the tree and the boy? Obviously, when the boy reaches this point, which is the foot of the perpendicular drawn from the tree to this line of motion of the boy. So what we have done is, हम यहाँ पे देख रहे हैं velocity of boy with respect to tree. ये हमने ड्रॉ किया, इस वेक्टर को ड्रॉ किया हमने यहाँ पे, जो यहाँ पे ये लाइन दिख रही है, ठीक है। और फिर हमने क्या किया कि जो रेफरेंस ऑब्जेक्ट था उससे इस लाइन के ऊपर परपेंडिकुलर ड्रॉप किया। उसकी लेंथ कितनी आ रही है? यहाँ पे d आ रही है। तो यही परपेंडिकुलर डिस्टेंस निकालने का तरीका होता है, लीस्ट डिस्टेंस ऑफ अप्रोच निकालने का। सो d इज द लीस्ट डिस्टेंस ऑफ अप्रोच बिटवीन द बॉय एंड द ट्री। सो फर्स्ट थिंग इज take a reference point, preferably one of the two objects, find relative velocity between them. Third is draw perpendicular from the point of reference on this velocity. This will be the least distance of approach between them. तो चलिए यहाँ पे लिखते हैं अब velocity of A with respect to ground हो गया यहाँ पे 10 j cap, of course मीटर पर सेकेंड है। वेलोसिटी ऑफ B विथ रिस्पेक्ट टू ग्राउंड हुआ यहाँ पे 20 माइनस आई कैप, ठीक है। दिस इज द एक्स एक्सिस, दिस इज द वाई एक्सिस, राइट। नाउ लेट्स टेक B as the reference point. So we will find velocity of A with respect to B. This is velocity of A with respect to ground minus velocity of B with respect to ground. So this is 10 j cap plus 20 I cap, or let's rearrange it, it is 20 I cap plus 10 j cap. Now draw the line of motion, or draw this vector VAB starting from A. So before drawing this vector, first try to find out what is the direction of this vector. So tan phi is nothing but 10 upon 20, or it is 1 upon 2. So this angle phi is certainly less than 45 degree because tan inverse of 45 degree, tan 45 degree is 1. So obviously this vector VAB will be drawn along this line, right? So this is the direction of motion of line VAB, or it is car A is moving along this line with respect to B. So this angle is phi, which is tan inverse of 1 by 2. Now the next thing is what we have to do is we have to draw a perpendicular on this line from the reference point, which was B in this case. So let's call this point as C. So this length BC is D, which is the least distance of approach. So we get D as, D is nothing but this length is 10 kilometers, this length is 10 kilometers, this angle is 45 degrees minus phi, right? So we get D as sine 45 degrees minus phi as D upon 10 kilometers, or we get D as 10 sine 45 degrees minus phi kilometers. So we have the least distance of approach as 10 sine 45 degree minus 5 kilometers. The value of phi is very well known to us. It is tan inverse of 1 by 2. So remember the process. I repeat it. First is, if you want to find the least distance of approach between the two objects, fix one of the objects, take one of the objects as a reference object, find the velocity of the second object with respect to the reference object, draw the velocity vector, drop a perpendicular from the fixed object on that line of motion, you will get the least distance of approach. This is the least distance of approach, LDA, least distance of approach.